This tutorial shows you how to calculate the minimum required sample size for the one sample t-test using g-power. A general introduction to g-power is linked in the info cards and also the video description. When we start g-power, we get this overview by default. We now need to select the one sample t-test first. This can either be done via test family and statistical test, or via tests, means, difference from constant. Now you have to select the type of power analysis. Since you have to calculate the minimum required sample size in advance, you have to select a priori. The first input parameter you have to specify is whether you are conducting a one-tailed or two-tailed test, not to be confused with one sample or two sample test. Two-tailed means you cannot tell in advance whether your observed sample mean might be above or below the hypothesized mean. If you do, however, select one-tailed. The second input parameter needed is the effect size Cohen's d. The conventions for the behavioral sciences, 0.2, 0.5 and 0.8 for small, medium and large effect sizes, are shown as a tooltip and are taken from Cohen 92, a power primer. If you have research field specific thresholds, use those instead. However, if you have a preliminary study or comparative study where a Cohen's d already exists, then you should rather use that. The third input parameter is the alpha error probability, which is the probability of committing a type 1 error. In short, this is the probability of wrongly rejecting the null hypothesis. 5% is the typical convention, 1% is a bit more restrictive. A value above 5% should be avoided. The fourth and final input parameter is power. Power equals 1 minus the beta error probability. Beta error is the type 2 error. In short, this means falsely retaining the null hypothesis. 95% power is typical, meaning you have a 5% type 2 error probability. In some research fields, 0.8 is used here. This means you automatically accept a type 2 error of up to 20%. If you have power lower than 95%, this calls for a reasonable justification. Finally, hit calculate to see the minimum number of observations needed to detect the presumed statistical effect with the predefined type 1 error probability and power. As a rule of thumb, a smaller effect size and a larger power require more observations than the other way around.